All right, we're going to continue with Arithmetic Series. So if you have not watched the Ed Puzzle introducing a series and Arithmetic Series, make sure you do that first before watching this. Otherwise, it won't make much sense. We're going to talk about something new called sigma notation. This is something people use definitely in some higher level math classes. So if you see a calculus, you may have to do this, which is why we talk about it in pre-calculus. So this sigma notation, Greek letter, this is kind of, as this says, this is the, what variable are we using here? This is the first value. So whatever this value is right there, sometimes we start at 1, sometimes you can start at 7, 8, 10, whatever you want to do. And then as you see, the number up top is, so you're going to start with 1. And essentially, you're going to plug in 1 for this n. So basically what you would do, so if it was this function here, you'd have 4 times 1, because that's what you're starting with. And since this is a series, we're adding. And then keep on going. Well, the next number after 1 would be 2. So it's 4 times 2, and then 4 times 3. And you'd keep on going until you plugged in the last number, which in this case is 6. And you could theoretically write all of these out, then add them all together. But of course, we've learned that there are formulas to kind of help us out with that. So when you see the sigma notation, the first thing I would do is start writing it out. So take this number, plug it into here, then take the next consecutive number, and then keep on going until you plug in the last number. That usually is going to help you out. But I would definitely take notes on that. So here's an example. So I have the sigma notation, n equals 6. So again, that's what you're starting with. And we're going to start and plug in 6 and 7 and 8 and 9, dot, dot, dot. And then the last number we're going to plug in here is going to be 28. So if I start that, so I've got 5 times my first number right there will be 6. Minus 17. So I'm going to calculate what that is. That's my first number. So I'm taking this n equals 6, plugging it in for n. And then my next term, remember the difference between a series and a sequence is a list of numbers. A series is adding those list of numbers. And so here I'm going to plug in the next consecutive. I just plugged in 6, and the next one's going to be 5, or 7. So it's 5 times 7 minus 17. And you can keep on going. You can do 5 times 8. But you can kind of also see what the pattern's going to be here when we're going to continuously do that. But we can do one more. So in this case, I've got 5 times 8 minus 17, and then plus dot, dot, dot. I'm going to plug in the last one, which in this case is going to be 5, and then times this 28, and then minus 17. And so we just kind of take a calculator at that point and say, okay, what is that going to give me? So if you take any calculator you have and you do 5 times 6 and then minus 17, you're going to get 13. So I have 13 here. Plus, and then next one, do 5 times 7 minus 17. That'll give me 18.
I just want to wish you good luck. We're all counting on you.
Mr. V just came in my meeting. Say hi, Mr. V.
Hi, Mr. V.
And then the next one, 5 times 8 minus 17, I get 23. And you can kind of see that this is going to continue in this pattern. And then the last one, 5 times 28 minus 17, and that'll give me 123. So I get all these different numbers. So based from this thing, we could start listing out things we know. Well, first off, we know the first term in this series because that's 13. I can also find the last term in this series. So the last term, that's a sub n, that's 123. We can quickly find what the pattern is because this is arithmetic. These are increasing by the same amount each time, which is 5. And notice that I have a 5 here. That's not a coincidence. So because this is a linear function, this slope value essentially can kind of help you find that. And so based upon the formulas that you guys have already talked about watching the other ones that we've kind of discussed, we know we can also find n here in a second, but we know the first term, we know the last term. So we're able to quickly do that. Now, the last thing I want to kind of mention is to find n. Whenever you're finding n in sigma notation, it's always the top number minus the bottom number, and then you always add 1. So, if I list the numbers between, if I'm going from 1 to 3, for example, if I just do 3 minus 2, or 3 minus 1, that's 2. But remember, if I count out numbers 1 to 3, that's 1 and then 2 and then 3. There's actually 3 there. So you take this top minus the bottom, subtract 1. And so in this case, that'll give you 23. So based upon that, we can use our formula now. So I know that S sub n equals n divided by 2. and then we add A1 plus A sub n. So for us right now, I'm going to find the first 23 terms. And that'll give me 23 over 2. My first term was 13. And then my last term we said was 123. And so I just go ahead and take that and plug it in where I want to. So we had 23 divided by 2. Come back there. My first term that we had was 13, and my last term was 123. So 13 plus 123, and that gives me a total of 1,564. So that means that's that summation. So these are very similar to the other ones, although they certainly look a lot different. So the difference between the other ones that you learn how to do is you'd want to go ahead and write these terms, at least the first couple terms out and the last term out. So reminder, take whatever number this is, plug it in first. That's where I replace this n with 6, and then the next consecutive number 7, and the next consecutive number, ... and then I plugged in the last number up at the top. Okay, word problem. A video game tournament in which gamers complete in multiple games and accumulate overall score pays a top 20 finishers. First place is 5,000. Second place is this. So we're kind of basically starting. We're saying, okay, I've got 5,000, and then it goes down. Second place is 4,800, and then 4,600. And you can kind of see as we go down. So we want to find all of those. Now notice that it says the top 20 finishers. So here n is going to give me 20. I also know the first term because that's at 5,000. I can also find my common difference. So notice that this is decreasing, which means your D common difference is negative. So what is it decreasing by? Well, that would be decreasing by 200. Now notice I don't have my last term in the series. So I don't know what the 20th place is going to get. And theoretically, you could use your arithmetic sequence formulas that we learned last week. However, we do have this embedded in there. This one is essentially doing that to you. So as you saw in the first video, you're replacing this a sub n by what we did last week. And that was this formula that we used to find some nth term. So it's doing this for you at the same time. So if you plug this in separately and then use this formula, you could, but it's a lot easier to be able to use this one. It's a lot more helpful and just a little bit quicker. So I'm going to do that. So I'm going to find S of n equals, we did n divided by 2, and then 2 times a sub 1 plus n minus 1 times d. So I'm going to use that to help me. So I'm going to say, well, I'm going to sum up the total amounts of all 20 places. So n divided by 2, that's 20 divided by 2. Here you're doing 2 times your a sub 1. That's the first term in your series. So in that case, that's 5,000 for first place, plus n minus 1. So I'm going to do 20 minus 1, and then I'm going to times that by negative 200 because the pattern, what this is decreasing by is $200. So I'm going to go ahead and then take that and plug it into my Desmos. So we already know this. I'm just typing in. We know that, of course, is going to be 10. And then I'm going to do 2 times 5,000, and then plus, and we know we're going to do 20 minus 1, which of course is 19, times that by the negative 200, and you get 62,000. So I'm adding all of these up. So this final answer means that the person in charge is going to be spending a total for this tournament of $62,000. And some other applications that you can use is like, let's say you have an auditorium and you start, the first row starts with 10, and then the second row has 12, and then the third row has 14. You can calculate how many total seats an auditorium would have.